These are some definitions for the kinematics unit, specifically with regard to motion. We'll have some definitions later that have to do with forces. This is in your book, Chapter 2, Section 3, and Chapter 3, Section 1, so you'll probably want to follow up with reading those sections to give you a fuller picture of what we're talking about. The first definition is distance, and when we're talking about distance, we're simply talking about how far an object has moved. So when you walked the 30 meters down the hallway, your distance was 30 meters. That's how far you had moved. And the unit for that is m for meters. The next definition is displacement. That's how far an object is out of place. To displace something is to move it out of place. And when we say out of place, we mean from the start. And that's also measured in meters. So that, again, when we talked about if you walk down the 30 meters and then walk back to the start, your distance is 60 meters. That's how far you've moved. But your displacement is 0 because you have not moved at all from the start. So distance and displacement may be the same thing. For example, when you walk just one way down the hall, your distance and displacement were 30 meters. But if you made that a round trip and walked back, your distance is 60 meters, your displacement is 0. The next definition is speed, and that's how fast an object is moving, measured in meters per second. So when you calculated your speed on the walking lab, you had your 30 meters, that was your distance, divided by your speed, divided by your time in seconds, and so that's how you got meters per second. You can think of speed as far as driving a car. We talk about miles per hour. That's the number of miles you go in in 1 hour. Although you can calculate it by doing the total number of miles and the total hours it took you to drive there. Velocity then is the rate at which an object changes its position. And this brings in the word rate. And we're going to talk about what rate means in a little bit, but keep that in mind that this specifically is referring to a rate. And it incorporates speed and direction. So your unit is going to be meters per second plus the direction. And your direction may be a compass direction, such as north. It may be forward or backward or to the right, to the left, something like that. But it's the rate at which an object changes its position, which is why when you walked down the hall and then back, your velocity was 0 because your position, your displacement was 0. So go back to that idea of displacement. And then acceleration. And acceleration is another rate. So here we've got a rate here and a rate here, and we'll talk about what that means in a second. It's the rate at which an object changes its velocity, and velocity being the speed and direction. And that's measured in meters per second squared. Because velocity is measured in meters per second, and then it's over time, that's how we measure rate, in a certain amount of time, which means that the rate of change of velocity is meters per second, or meters per second squared. And so if you're changing velocity, and velocity is speed and direction, there's actually 3 ways you can do that. And this is where we get into another one of those words that is different in science or in physics from what a lot of people think. A lot of people, when they think acceleration, they think speed up, go faster. However, if velocity is speed and direction, and you change velocity, you could change your speed by speeding up, increasing your speed. You could change your speed by slowing down. That is also acceleration. It's generally called negative acceleration. And you could change your speed by going the same speed but changing your direction. So think about running around the track outside at school at a constant speed. Your speed may stay the same, but because your direction is changing, then you are accelerating from a physics standpoint. Now, when we talk about rate, we're talking about how quickly something is changing. So the way these link together is that velocity is a change of position, so that relates up to here, and then acceleration is a change of velocity. And as we start to graph these things, you'll see how those relate to one another. Please feel free to put any comments or any questions in the comments section on YouTube so that we can answer those in class.